Hello everyone, welcome back to Vertigo. Today we're going to talk about roll center. I got a new mic, so I hope you can hear me well now without hearing the sound of the ceiling fan. Anyways, in the last video I briefly explained what roll is. And when I talk about roll, I'm not talking about the roll you do at night in your bed when you can't sleep. Get it? Because you roll around in your bed. Anyways, I would recommend checking my previous video out after you're done watching this one. Don't leave right now, alright? I will briefly explain the whole concept of roll again so you can easily understand the, the roll center. Roll is the rotational movement of a car when it's viewed from the front. So if you look at this diagram, when the car is making a right turn, of course this is the front view of the car, so the right turn would be like this, in this direction. This is the direction of turn. The suspension mounting points, which are these, the suspension will force the vehicle in the direction of turn at these mounting points. But the rest of the vehicle, due to inertia, will move in the opposite direction, like so. Now, due to this, the car experiences a rotational movement. I will explain later in this video why that is. But that rotational movement, that is called roll. Now we're gonna move towards the roll center. The roll center is an important aspect of a car's handling, especially for race cars. Because during cornering, you want the car to be as stable as possible. Now to find out the roll center, we will first have to find the instant center. For that, we will have to cut this diagram in half to make it easier to understand. So I'll do that now. Now to find the instant center, we're going to have to extend the, the upper control arm like so. This is just to figure out where our roll center is, or for now, instant center is. We're going to use the instant center to find out the roll center. Now the first step is complete. We extended the upper control arm. The next step is to extend the lower control arm. So extending the lower control arm, of course, what the heck happened to my marker? Sorry about that. We are extending our lower control arm right now. Now there is going to be a point where both of these lines intersect. We're going to mark that point, because why not? And this point right here is called, hold on. I'm gonna get a new marker because this is embarrassing. Sorry about that. I got the new marker, so we should be fine now. Anyways, the point that we just found out, this is called the instant center. To explain what instant center is, we are going to assume that this whole suspension is a rod, we're going to call it, or a swing arm is a better term for it. As you can see, I've drawn the swing arm right here. Now, this point will act as a pivot point for the wheel, the tire of the car, meaning that the tire will rotate around this point because of course the movement that the upper wishbone will provide will be perpendicular to the wishbone itself, and the movement the lower wishbone will provide will be perpendicular to it, the lower wishbone, of course. So these will result in a sort of a rotational movement. We can simplify it to a swing arm, which pivots about the instant center, which we just found out. So this point is the instant center. And we assume that this is the center of rotation of the wheel. So when the wheel goes over a bump, it will rotate around this point. So we assume that this is going to be a circle. It's going to be a circle that the wheel is going to rotate around. And this is the center of that circle. Good? We good? You with me? And this is what this instant center is showing us. The instant center is the center of rotation of the wheel at that instant. Of course, when the wheel moves up or down, the direction of the wishbones change, which will end up changing the location of the instant center itself. Now the instant center is not fixed. As the wheel moves, the instant center shifts. That's why it's called the instant center. Otherwise, it would be just called the center. Now that we know how to find out the instant center, we can move on to finding out where the roll center is. Now I've only left the instant center point on the board, so we can move on with the explanation and you can see the board a little bit better without any of the mess. To find the roll center of a symmetrical suspension, we assume that this is going to be the contact patch of our tire. The contact patch, of course, being the point where the tire meets the ground. And after finding out the contact patch, we're going to extend a line from the instant center to the contact patch of the tire. This is not a straight line, but you get the idea. The point where this line meets the exact center of the car is called the roll center. This point will be the roll center for this car. When the car is taking a turn, the control arms are not symmetrical. So this method will help you find out the roll center when the car is in the middle of the turn. So in the previous method, we extended the control arms using dotted lines for one side of the car. We're going to do the same for both sides in this diagram for this case. So let me just do that. So now we know the instant centers for both sides of the car. The next thing we do is, of course, again, similar to the previous method, we draw the line between the contact patches and the instant center for each respective wheel. Note that we're going to connect the contact patch of the tire with that respective tire's instant center, not the other ones. For this side of the car, the instant center is this. And for this side of the car, the instant center is this. Now I've cleaned this up a little bit and extended the lines from the tire contact patch towards their center, their respective instant centers. And the intersection of these two lines is the roll center. Now, to understand why roll center is important, we first need to know what roll center is, because I haven't really explained what it is yet. Now, remember when I told you the instant center is the center of rotation of a wheel? Now we have two of those wheels, and they each have their own instant centers or center of rotations. Now each side of the suspension will move around its own center of rotation or the instant center. But when we combine both of them, they interact with each other. And as a result of that interaction, they push and pull on the body of the car, which results in a new center of rotation for the body of the car. Now, this center of rotation that results from the interaction of these two centers of rotation and the movements around these centers of rotation is called the roll center. This is the center about which the body of the car will rotate when taking a turn. To simplify this, we will have to assume that this is the center of gravity of the car. During a turn, all of the weight of the car is assumed to act at this point right here, the center of gravity. So the body of the car will consider the roll center as the center of rotation, as I have already explained. So the movement of the body is going to be something like this in, on this circular path. But of course, it's not going to rotate completely. That's stupid. The rotation of the body will be around this path with the roll center as the center. But of course, as the suspension geometry changes, the roll center will also change. This movement of the roll center is called the roll center migration. When the car is making a right turn, we assume that all the weight of this car will push the center of gravity in the opposite direction of the turn. So the center of gravity will be pushed in this direction. We are going to call this force the big F. Now we know force times distance is moment. So we can see there's a distance right here. We're going to call this distance d. The resulting movement will be rotational. Of course, as I already told you, the, the suspension linkages will force the body to move in a rotational path, not a linear path. The product of this force and this distance will result in a moment. We call that the roll moment. Now, if we increase this distance, the roll moment will increase, meaning that the roll of the car will increase. And as the roll increases, it becomes increasingly difficult for the driver to control the car. So it's better to keep the roll to a minimum. And one way of doing that is by decreasing this distance. So if we, let's say we put the roll center right here. Now this teeny tiny little line you see here will be the distance d, which will significantly decrease the roll of this car. Wait, before we move forward, I forgot to mention a few points. First of all, as we decrease the distance between the roll center and the center of gravity, the amount of roll experienced by the car will decrease. And once the roll center and the center of gravity are at the same height, the car will not experience any sort of roll. And the second point, if the roll center is higher than the center of gravity, the car will experience roll in the direction of the turn, meaning the top of the car will point towards the center of the turn that you're taking. So yeah, these were a few points that I forgot to mention. On with the video. Now based on this explanation, you might be thinking, well, it's simple. For the next race car I design, I will keep the roll center high, as close to the center of gravity as possible. It's not that simple. A high roll center is also not ideal for a race car because it results in something called the jacking effect. To explain what the jacking effect is, we will move back to the point where we cut the car in half and figured out where the instant center was. To have a higher roll center, we will need a higher instant center location because, as I said before, the intersection point between the two lines that connect the instant center and the, the contact patch for each side of the car is the roll center. So if both of those lines are inclined more, that means the roll center will be higher. Now when the car is cornering, a force acts on the contact patch, which makes it turn. So again, let's consider the car is turning to the right. like so, there will be a force that will be acting on the contact patch of the tire in this exact same direction. Let's call it the FC. The instant center is the center of rotation. So there will be a reaction force at the center of rotation that will try to react to this force and cancel it out. For explanation purposes, let's say that this is the accurate distance between the height of these two forces, the force and the reaction force. To explain this better, I will draw a line between these 2 points. Consider this line to be your finger. Now hold your finger in an inclined position like that. Try and put some force on your finger in the opposite direction while also trying to keep this hand stationary. This one right here. All right? You'll see that my finger is trying to lift now. This exact thing happens in the car. The body will try to lift due to the reaction of these two forces. This is called the jacking effect. Now there's a detailed explanation by a channel called Suspensions Explained. I will leave a link down in this description. He's made a two-part series on Roll Center. So I'll put a link to both of his videos down in the description. So check it out if you want to learn more about Roll Center. As a result of these forces, the body of the car will try to lift. And if this line is inclined even more, the jacking effect will be more severe. Having the jacking effect of in your car causes all sorts of problems, especially in race cars. While taking a turn, you don't want your chassis or your body or the body of your car to lift, which might end up decreasing the amount of traction that you have on your tires. So especially for race cars, you want as much traction and grip as possible. Another problem that is caused by a high roll center is wheel scrub. When the car goes over a bump, it will experience camber change. And for a high roll center car, that camber change will be more than it would be for a low roll center car. I hope you can see this diagram and understand it, because I have drawn an exaggerated view of this car when this wheel goes over a bump. This right here, this is the upper control arm, and this is the lower control arm in that case. As you can see, it faces significant camber change. And due to this camber change, the contact patch of the car will move side to side. This is called wheel scrub. And this causes a lot of unnecessary wear of the wheel. Unnecessary wear means more frequent pit stops, meaning that you lose a lot more time on the track. That also results from a high roll center. That's it for this video. Hope you enjoyed watching. Hope you understood everything I tried to explain. Leave a like if you did. If you have any questions, be sure to leave them down in the comments. I will try to answer all of your questions. And I've put the links to all the videos that I mentioned in this video down in the description. So be sure to check them out. And yeah, that's it. Hope you enjoyed it. Goodbye.